Welcome to Tacit Talk, episode 27. I'm your host, Conor, and today with us we have two guests. The first time ever we've had two guests. We've had, I think, 4 guests in the past when we've done our implementer panel, but we are having I wouldn't say it a debate, but more of a conversation style episode. Our two guests today with us are Hsu, who I'm sure all of our listeners are familiar with, and our second guest is Jon Smith. Welcome both to the podcast.
Thank you.
Hello.
And I think I'll say briefly about Aaron, even though, like I said, most of our listeners and viewers are probably familiar. He's a multi-time guest, most recently guest on episode 100 of ArrayCast. But before you knew him from ArrayCast and all of his talks online, you probably knew him from his Parallel GPU Code Defunds compiler, which he has done many live streams and articles online. Links will be in the show notes later if you want to check that out. For Jon, and I guess before I introduce Jon, what this episode is it is an extension of an episode from another one of my podcasts, ADSP. It was specifically episode 197. For those of you that are a listener of that podcast, Aaron and I were at the Eagle Pub in Cambridge back in August when we were attending Iverson College. We recorded for about an hour. We split that into 2 episodes, and one of them I asked Aaron about Tersity and why it was important. It's something I feel is important for programming, but I have a hard time expressing why that is in a convincing fashion. And we ended up having a great conversation. And then Jon, who is a listener of ADSP, went to our GitHub discussion and posted a very, very thoughtful and a very, very long response. I think it was about September 6th was roughly the day that post went up. Aaron replied and said, "Let me think about this. This response is amazing, but there's a lot in it, and I need some time to think." And then I think a couple months later in December, Aaron got back to Jon, and then Jon said he was going to get back to Aaron, but he also needed some time to think about it. But in that post, he also said, like, anytime you can get Aaron back on would be amazing on one of the podcasts. And then Aaron said, well, really, if I'm going to come back on the podcast, I feel like you should be there so we can have a back and forth conversation, because Aaron was taking the side of, I agree with Conor, Tersity is extremely important, economical expression, etc. And then Jon was coming it from a more, I don't want to say pragmatic, but definitely experience-driven view of, I love the way a lot of these ideas sound, but in practice, I don't think they're great for working in a team environment and for communicating with your coworkers and for even yourself, if you're writing something, having to understand what it means, a few months later or years later. Anyways, that's the background. Links in the show notes to both episode 197 from ADSP and also the last episode on this podcast, which also brings up a question that Aaron asked earlier. Why are the numbers skipping on Tacit Talk? That's because if you are only subscribed to the YouTube podcast, we only do the live interviews on this platform or media. But if you're subscribed to any of the, Spotify's or Apple Podcasts, there are other episodes in between. So episode 26 was actually a podcastified version of the GitHub discussion between Jon and Aaron. So you can go and listen to someone that sounds like Obama reading off these. I mean, the app that I use calls it Mr. President's, probably for legal reasons. But it's my favorite voice. So anyways, with that monologue out of the way, I'll throw it over to Jon if you want to just introduce yourself a little bit, and then maybe we'll take a break, and then we can hop into the continuation of this discussion.
Sure. Well, so everyone, as I said earlier, when no one else was listening, everyone knows me, Jon Smith. If you haven't heard of me, go find an example. No, I know I'm wearing a C++ hat, but that's because that's my current role. I promise there's no specific agenda as far as that's concerned. Now I do, for almost the last decade, I've been doing compiler engineering and mostly with LLVM, not front end stuff because I would lose my mind if I had to deal with that. Middle end, so optimization pipeline. More recently, I've just been doing general Windows programming, application and kernel programming, driver development, basically. Yeah, I mean that's pretty much it. That's before that I was in the Navy doing a bunch of stuff that is not interesting. So
Well, I mean, you say
About it for me.
currently C++. Does that mean you've worked in different technology stacks? Just so we've got people live in the chat that might be asking questions, and so just so that they're
Mhm.
familiar, is it been C++ from basically the beginning of your career till now, or have you worked through different languages?
There has always been at least some C++. More recently, it's been the dominant language. But yeah, I mean, I've worked with Python, Java, C Sharp. Um, I I think that's it for the big languages. I can't remember any of the maybe any of the more specific ones,
Okay.
but the
Have
major
you
ones,
done any Rust?
if you heard of them, I have, but not
Oh,
for anything meaningful, if that makes sense.
okay. Yeah.
Because I was going to say, so that all those languages, Java, Python, C Sharp, C++, those are all top 10. So they're the most in demand, at least at the moment. Things can change. And okay, so good to know. And I mean, for those that have forgotten, Aaron, I mean, you obviously work for Dialogue Limited, are a full-time, all-time APL programmer. But at one point, you did a ton of Scheme. You were highly
Yeah.
involved in that community, which is a Lisp. Any other languages you want to throw on your stack? Just seeing as we're talking about Tersity and what folks have used.
Well, so if there's a dynamic untyped programming language that has seen the light of day somewhere in the past like 20 years, I've probably played a little bit with it. But I always, ever since I got into Scheme would be my dominant language. And then C, C++, Java are all languages that I had to work with. C Sharp, .NET languages. Those are ones that, I'm pretty comfortable with, but I've worked in like formal proof languages, ACL2, Isabelle, Coq. Actually, what's it called now? I don't know. They changed the name on it. Like ML type languages. Actually, the first programming language in a business that I actually did was Delphi, which, if you're not familiar with, is Turbo Pascal.
Yeah, the helmet language.
Yeah, and that was interesting because I was really young at the time. I was basically doing a type of internship because my family had some, friends that offered me an early internship, and I had no idea what was happening in the object system at all. And I was just reading these senior guys' code going, how on earth did they make any of this go? And it was great. It was terrific fun. It was on programming image processing on check processing machines. So that was
Oh, wow.
a really fascinating little space. But like the long tail of languages I've played with is pretty high. I like to play around with a lot of languages, but I tend towards the untyped languages compared to the heavily statically typed languages, and I always have, more or less.
Yeah, it's I always forget actually that you must do I don't know, substantial is the right amount, but you've definitely coded at least in the past, I would assume a substantial amount of C++ because you target ArrayFire for your
Yep.
GPU backend, which is a C++ library that targets different hardware,
So
including the GPU.
yes.
So.
So the backend used to be, I tried to target LLVM back in the day. Then I decided C++ was going to be better. And then now the runtime strips all the C++ out and it's just plain C. So we use
Oh,
the
wow.
C interface inside of ArrayFire and we dumped all the C++. But I did use C++ plus Boost plus Visual Studio IntelliSense plus their Parsec library at the time to do a prototype of the compiler's parser back in the day, and that was an interesting experience.
No kidding. I was going to ask,
That
how long
was
did that take to build?
so it took forever to build, but if you use the right compiler, you get useful error messages out of it. And because of the IntelliSense, it turned out to be a really interesting interactive environment for building DNF grammars. So I actually gained a lot of respect for Visual Studio at the time because of how powerful the
Oh, yeah,
IntelliSense was on top of that.
Say what you will about C++, but Visual Studio, it is still the
Visual
best
Studio
like IDE at like a high
some
level,
intense
like
stuff.
data breakpoints
Yeah.
when I discovered those, or they added them while I was using it back in, I don't know, 2017 or 18. And like the ability to just like check when, some
Yeah.
2 bytes or whatever changes. It doesn't always work because stuff moves around, but when it does, it's like,
It's
wow, that would have
powerful
been
feature.
4 hours of debugging right there.
Yeah, yeah. Oh, it's big. So, but I also have prototyped the compiler back in the day in like every possible language I could, trying to figure out how to make something go. So, I actually spent a lot of time doing eLisp programming because I used to use Emacs as my operating system. So there was also a lot of that.
All right, and that's where we are going to cut that. We've decided there's some topics we're going to avoid. Vim VI versus Emacs is one of them. We're not going to list the other ones
Yep.
at risk of having to talk about them.
Oh yeah. Oh yeah.
All right, so we've got the background set now. Maybe we'll go to John first because you were in the role of listener back in September when the episode, I believe, came out. And I don't want to paraphrase you, but you said you thoroughly enjoyed the episode, but then obviously, it made you think a lot, and there were things that you agreed with, things that you didn't agree with. So as best you can, seeing as we're like half a year removed from when that conversation took place, take us back and maybe give us your thoughts, and we'll go from there about the conversation and the topic of Tersity and whether it's a good thing or a bad thing for programming.
Okay. Well, so to start, I will say, before I really dive into this, I understand it. I understand the argument of having tersity in a language. But you said maybe not necessarily I was approaching it from a pragmatic or practical standpoint, more like team driven. And I think it could be both. But so first of all, Aaron, I would like to acknowledge one of his superpowers, which, Aaron, you're the most articulate person that I know. Like, you could explain that sea level water is actually a plasma, and I would be completely just nodding along, like, yeah, of course it is. Why wouldn't it be? And so the fact that you were able to do what you were able to do with APL is amazing. And the fact that you are arguing for this specialized terse language set fundamentally, that's I love it. That's amazing. And I'm so glad that you have that much faith in human cognitive ability. So as I said, APL wasn't one of those languages that I listed that I know. I know of it. But after that episode, and when I was, arguing that I don't think this necessarily works at a fundamental level, I went and okay, I don't feel comfortable saying that without at least trying to understand, specifically in this case, APL. So I didn't want to install like a special editor or anything to write the glyphs. I looked at some of the code. I went to go look at J afterwards because my understanding it's just APL but all ASCII.
Correct. I mean, to some extent, some people might say there's some differences, but yes, that is basically the description of J, APL with ASCII symbols.
So I will tell you, there is absolutely a difference. It is a wild experience comparing those languages. So I don't know APL, but looking at it, I can tell there is meaning in the code by itself. The structure, the glyphs, and everything are laid out. I can tell that there is meaning behind all of that. Looking at the same code written in J is an indecipherable wall. It's almost offensive to me. I don't know how else to describe it. And that got me thinking about something. The glyphs that are actually used in APL, they aren't really, I mean, maybe outside of math, they aren't really used anywhere else. So I think there's something to be said about all the symbols that are used in J. They're so common and they're used everywhere. You have the @ symbol and, the pound sign, all that. Maybe people who haven't used APL are more familiar with those symbols used in other contexts. So when we see them in a language like J, our ability to understand them, our brains resist the ability to understand them. It's like cognitive dissonance because we're so used to seeing them in other contexts.
Yeah.
So on the other hand, APL it's beautiful compared to it. So I really think that actually speaks to your argument that the terseness of that code is useful. It's really meaningful. But at the same time, it's still, to me, and I know you have a response for this, but it's still a specialized thing. It's a specialized domain of knowledge. And it's one more thing that I'm not sure works at scale.
Yeah.
Compared to using for lack of a better term here, the symbols and the keywords, I guess you could say, of other more verbose languages, because the familiarity is already sort of there. And I know you have a response for that too, but.
And if we're keeping track, we've already got one person in the chat, Archive. I mean, I know Aaron hasn't said anything. We've already got one person agreeing with John, so it's 1-0. Not that we're keeping score.
Yeah.
So basically my argument is I think Tersity is absolutely a fantastic tool, but I don't necessarily agree that it is something that can or should be applied at a fundamental level. That's where I would,
like the ground level.
Correct.
Right.
Yes.
Right. Okay. So I guess where would you? So assuming that you do see a place for it, where are you imagining that you think it would be useful to apply something like an APL level Tersity? Or is there a space? Do you feel like despite the beauty, it's the potential costs inside of a real project are just too high?
I don't think it's potentially too high. There is something to be said about boy, how do I put this? The specialized syntax of APL specifically, that is one more thing that I think is more difficult to learn in a general sense because of, as you said, institutional momentum has us using languages that don't typically use things that aren't found on the keyboard, right? So,
Right.
that's,
and the abstractions are different.
Sure. Yes, absolutely. I don't think that I can't rule it out absolutely, because clearly you have shown what it can do. I can't think of a better example than your compiler, honestly. So it absolutely can be used for any number of things. I'm just not sure how to extrapolate from that into what those special things would be.
Right. So then maybe I can tackle it from a different perspective. You talked about scaling, which I think is actually, this is the big linchpin, right? Because I think it's fairly easy to show APL in the small, and it's like this beautiful formulaic thing. You can build these little things. Then you go, well, what does it look like to scale, right? And I think a lot of your objection was not exactly in the small, but if we continue programming like that and our team grows and the systems grow and things get more complex, what happens, right? I think that was your skepticism, was that as the team grows, this becomes untenable at some level, right? Mm-hmm. But I think maybe one thing would be nice to get some clarity on here is when we talk about scaling and we talk about teams growing, what do you see as the fundamental problem that leads to, what is the fundamental issue that you think maybe the Tersity might undermine or might make worse or exacerbate, or what is the thing that teams have to get a handle on as they grow? I mean, it's easy to say complexity, but
sure.
There's what type of complexity or what shape of it do you think is the impediment to scaling?
The number one thing that teams have to have is communication, and if you are unable to communicate the purpose of the code that you're working with, then you have an immediate barrier to progression, basically. And unfortunately, because I will agree with you, we should absolutely have better tools for this. We, in the general sense, programmers, like I said, they aren't taught things like APL, and having to learn that specialized syntax delays communication, delays understanding of what the code's actually doing. So at scale, when you have a whole bunch of that, that makes that challenge like logarithmic in nature. So I don't see. There's a lot of bad C++ code too, right? Like that's almost a tautology, right? I can say that.
There's a lot of bad code, right?
Yes. So, I'm sorry, what were we talking about?
So I think it's a question of what do we mean by scaling problems, right? Like,
right.
And I think you were saying that if I'm understanding what you're saying is that as your teams grow, you need some way to communicate intent across more people. Is that sort of correct?
Yes, you need to be able to communicate intent across not just numbers of people, but different skill levels, different amounts of knowledge and experience. Absolutely.
Right. Okay. Yeah. So I think so. Since our well, I don't know. I don't know where we want to take this. I've been thinking about some things since our conversation, which I think dovetail into this, which is that the question about teams is I think a really big question to ask. But I'm looking at it from a slightly different perspective, which is like we've got Conway's law, right? Which basically says that one way of interpreting Conway's law is to say that the structure of your code is going to mimic the structure of your organization, right? And so the challenge with something like that is that as teams grow, they tend to hierarchically organize into parts that may or may not actually represent the best way to organize the code, right? And so you have a tendency for organizations to split too fast too early, right? Which then hinders their ability to evolve the code effectively over time. So I would like, if I were shaping the discussion around what the problem is with teams scaling, it's fundamentally a fight against Conway's law. Or that's the way I see it. I don't know if you could agree with that, or and so my question has been, well, what are ways in which we can tackle Conway's law, and are there alternatives? Because at some level, I actually kind of agree with you, is that if we face certain ergonomics around programming languages, then we do have communication issues, and those communication issues will always show up, and we need to be able to address them in some meaningful way in terms of like, how do we get new people into the system? How do we, one thing that, like, for example, the agile communities were really big is how do we get cross-pollination of knowledge of the code base, right? These are all things that people are trying to solve. For me, I think I would acknowledge that those issues, I think you kind of have to swallow them if you've got a big team the way it is. I'm kind of trying to speculate on, can we approach it in an alternative way, right? Is there maybe an alternative way from the ground up to tackle Conway's law in some fashion? And I've been thinking about this, and if there's a way to articulate it in a meaningful fashion, and I think two things emerged that relate to Tersity. One was, well, if you can allow teams to accomplish more in a given space, you can reduce the need to bifurcate or split those teams up as early, right? So if you can, and so then you can maybe, even though you can't really fight Conway's law directly, maybe you can reduce the number of cut points that are going to affect your architecture, right? If you bump if you increase the amount of things that a single unit of your hierarchy can handle. And that's where I think is the obvious way in which Tersity might be able to help these problems, is maybe you can reduce that space. But that doesn't address, I think, your concerns of, well, like onboarding or new people coming in or communication across teams, things like this. And that's where I don't think I adequately addressed that in our ADSP podcast, because I was speaking in terms of alternative to the software engineering discipline. But in terms of a team organization discipline, well, how do you deal with that? Because the traditional way that a team's, and correct me if this is actually, maybe we can do a confirmation here. My experience with teams as they grow is that they create explicit barrier points of communication where there's a communication between the teams and then the internal communication, and they don't tend to mix. So the way that I tend to see this go in code is the creation of hard API boundaries. So in like maybe 5 or 3 years ago, that would have been each team gets a microservice, right? And then they all are only allowed to communicate via their microservice or something. Or you get teams, each one is in charge of one aspect of the system, and everybody else talks to that system through a known API boundary. And every team builds some kind of explicit boundary in their code to wall off the code and force everybody else in the organization to only communicate through those boundaries. Do you feel like that is accurate, or do you see something different?
I am probably not the best person to ask for that because I 100% do not follow that. But I think you're right. I think that is the way it is done in general. I am a forgiveness over permission type of person. So if someone needs something, I expose it. So no, I think you're right. I think you're right.
Yeah. So it's interesting that you talk about the exposing things, because my solution perhaps to the tersity scaling problem would be to address architecture by finding ways of developing implicit architecture that allows you to not have to build as many hard API boundaries. So if we can design our architecture and our systems in a way that has a lot of implicit communication but doesn't reify those boundaries explicitly, then the teams perhaps can move a little bit more dynamically, and the tersity problem might not become as much of an issue because you can now leverage tersity to shrink that code base, and everybody can still take advantage of implicit conditions while they're working, but it doesn't have to sit in the code. It doesn't have to make the code big. And so that's one of the things, this sort of like implicit constraints or implicit expectations or implicit architecture in the data flow might be a way to help leverage tersity in the team scaling problem. And so like in my compiler, one of the ways in which I sort of manifest this is that where normal people would have function or sub-function boundaries in the code, I often just have a block of code followed by another block. And they form sort of basic blocks in the architecture. So where most people would have a class or a namespace or a module, I just have a function. And where most people would have a function, I just have a block of text. And I organize the code such that these blocks of text only need to appear in these one spots, in these single locations. And so the entrance and exits to these, same as a basic block, are really, really clear. And so then you can sort of implicitly define the constraints around entering and exiting one of those blocks. So if you bring another person in and they need to work on some aspect of the system, that aspect of the system may be further up in the compiler or it may be lower down, but you can sort of divide up the work based on sections that people are working on without having to introduce the API boundaries. And so it's sort of a shift down by leveraging the tersity to create these implicit contracts instead of making them explicit. Now, to your point about brain power, I think one of the things that I'm expecting in that case is that you do have to sort of come in and learn that culture, right? You have to learn that idea. Mm-hmm. And that's part of the onboarding process, which if you're not used to doing that, like if you're always coming from the Java OOP, everything is defined through an API interface, something or another, that's very, very different. And I don't think I can argue honestly that there isn't that cost involved, especially coming from something else. But my vision would be that we can amortize that cost by making it more common. And so more and more people get used to it, more and more people expect it. And so it becomes a way of working, sort of like everybody would have found OOP very difficult to work with in, say, 1993. But by 2000s, if you couldn't work with an OOP system, then, you kind of had missed the architecture boat on some levels.
So I want to kind of interject here because I've had this thought in my head, so I'm just the moderator here, so I'm just going to kind of guide.
We're bringing you in. We're bringing you in, Connor.
Yeah, you gotta weigh in here.
No,
No neutrality here.
I don't want to weigh in. I just want to ask questions as we go, so I can get my I have the privilege of being basically a live listener with a mic that gets to ask my questions instead of having to ask them in the chat and then wait for me to ask them. Which, if you do have questions in the chat, feel free to post them. But so my question is, we're talking a lot about, the onboarding and the ability to scale with a language that is potentially more verbose. Well, not potentially. C++ and Python are definitely more verbose than APL. I think we can all agree on that. But the thought I have in the back of my head is, as you two are going back and forth on this, is this just a function of the fact that we live in a world that, personal computers decided to install BASIC on them and not APL, and that there's the anecdote that has been told from time to time on Arraycast and in different spaces that the IBM 5110 and 5100 had an APL BASIC toggle on it, so it had two different modes. And then at some point, Bill Gates, he had APL, manual in his desk, and his goal, even in his famous note to shareholders, he mentions, that people are stealing his software and that he wants to write an APL, but what's the point if people are just going to steal it? APL gets mentioned in that letter. But we live in a world today where APL didn't get implemented on those computers, and everything, for better or worse, was kind of inspired by BASIC, which was inspired by Fortran. And so we live in the world we live in today. And I guess my question is if we lived in a parallel universe, would potentially your opinion be different, John? Or is it more than just the fact that most people aren't familiar with this technology? And even if they were, there is still actually something inherent in a symbolic language like APL that is different than the language and the text we read and use on a daily. Like, is it just that, like, we it's a function of where we are today, and if Bill Gates had chosen APL over BASIC, we wouldn't be having this conversation, or we'd be having it but in the opposite direction, or is there something more than just the symbols, or more than just that where we live today and that APL wasn't chosen?
Sure. So I guess my response to that is actually another question. Is that really the reason that we don't have APL everywhere today? Because, like,
was it an accident?
Right. Or to put it a different way, education has tried doing these things. I mean, APL's been around for decades. I feel like there is a reason we ended up with the languages that we ended up with, and I can't say we can put all the blame on Bill Gates for that. Although, sure, there's a lot to be said about that, because QBasic, what did I start with? But if we want to talk about terseness, writing mouse drivers with just hex digits in call absolute, I don't think you can get more terse than that. But
I started with QBasic after flowcharts.
I want to go get my green book. Oh man.
Yeah.
So I feel like the reason that we ended up where we are is there is probably a lot of that. There's probably a lot of network effect and a lot of momentum, which Aaron mentioned, and I agree with that. But I also feel like a lot of this has been tried, and we ended up where we are based on how things played out, based on how accessible these languages are to people who are learning them, people who are using them. There's a lot of history there that I absolutely know nothing about compared to Aaron. So I 100% defer to what he says on that guard. But that's what it seems like to me. We have tried these things in the past, and we are where we are because of accessibility and ease of use. I could be wrong.
And I think actually there's some truth to that. But I think it's we have this, I think, maybe a combination of network effect, hardware effect, business economics, and actual computer science knowledge, right? So if you look, the hardware one is fairly easy to see, which is that if you look at the times when APL was doing pretty well, you'll see also that it coincided with a lot of parallel hardware research. So there's some famous cases in the 80s and maybe the AVX 512. Those systems map really well to APL. And so in some of those systems, APL was the first system on explicitly mentioned simply because it was easier to get that onto the parallel systems compared to other languages. And we have, I think, the opposite effect, which is that some machines were just way better at executing something like C or an ALGOL type language compared to APL. So one of the classic, and APL had real problems with this, which is that it was very easy to use too much memory back in the day with an APL system. And so that worked okay if you had the IT support of a large mainframe system. But if you're on a small microcomputer somewhere and you're just starting out and you don't have that support, yes, you're not going to get business support. That was one of the things that the APL vendors messed up, right? In the 90s, they didn't adequately support the microcomputer space. But also, we were at a point where a lot of our knowledge about programming was not at the same level as it is today. So a Lisp is a good example where when Scheme sort of really showed what you can do with first-class procedures and lexical scope, that changed the programming landscape because we now had a way to handle these things. And I think one of the real problems was that we didn't know how to use APL as effectively as we do today. And we did figure out, thanks to works from people like Dijkstra, how to use structured programming really, really well. We figured out solutions to that. Whereas some of the things that you needed to, that APL was harder to apply at, we didn't have as good a training on how to think about those problems. You didn't get into that. And a lot of the academic community, when they communicated, how do you solve these problems? They used structured programming. They didn't use an APL type tool to discuss it, partly because they thought it was cheating, right? That was a classic version. That was how, people just use structured programming to talk about these algorithms, but that makes it very difficult to then communicate to the rest of the world. How do you do these things in this array-oriented way? And that's always been a problem that we've had in the communication literature, the education literature over time in a university, is parallel style programming has always taken a back seat to Fortran-esque or ALGOL-esque types of programming. And that has greatly affected what people knew how to do, right? So that's a little bit of the network effect, but also legitimately, there were things that we just didn't know how to do well, or they weren't put together in a way that allowed us to know how to build more rich applications, right? Now, if you look at like in the interim space, you've got a lot of people doing really cool stuff with APL systems. But those were people in the business spaces or the other spaces, not the people teaching the next generation of computer scientists how to solve problems. And I think the APL community did not necessarily do a very good job figuring out how to teach new generations of programmers how to think like an APLer.
That's unfortunate because that I 100% can see the value of it for sure. And that's, I can't go back and change the past for sure, but yeah, that is unfortunate. But so also that made me think, so full disclosure, I'm clearly from that school of Dijkstra. That's how what I learned. That's what I grew up knowing.
Right.
Kind of something that you said made me think of what we're talking about before, this inertia of education. What is it about structured programming that makes it unable to be as practically terse as what you're describing? Because actually, Connor, you brought this up too. Like, we don't write every single for loop. That's what, stood find if is for, or, that's why we have functions, really. And those can be expressed in maybe not single glyphs, but as simple words or things that are still understandable. I want to stop using that word because it really doesn't. You can understand glyphs, notation, all that things,
but they're a shorter step between what people say learn in a university to something else, right? Those combinators are the amount of difference, the difference between applying a new combinator, which is a function, once you already know first class procedures and map or reduce or a for loop. It's not that far. Once you've got, it's a little easier, a little more accessible compared to, oh, you're going to learn a totally new way of modeling everything.
Yeah.
Yeah. Yeah, and I think so. You were bringing up the main point of why can't those be as terse, right? Is there something fundamental in that, the lack of tersity there? And I think probably, yeah. If you just go to combinators, right? If you stick to just combinators, well, actually, let's split this up. You've got strict traditional Dijkstra-esque programming, and then you've got combinator-based programming, or programming that will use more higher order functions to do iterations, right? So that's like our modern JavaScript or Haskell or the for eaches and the maps and the finds and all these. So if you look just at pure Dijkstra, the entire point of that was to get very meticulous about exactly what the state of every progression was through the system, and fundamentally your syntax maps to your control flow. And the logic of the system was encoded in the control flow as well as the variables. So the variables themselves were scalar units that operated over branches and loops. And that was sort of the key elements. And if you stick to branches and you stick to those single efforts, then the only way to really write anything is going to be more verbose, because you don't have any collection type abstractions on top of that unless you make them. And then, then that means you've got this library of stuff. So there's not really a way of making that shrink that much, because so much of what you're doing is embedded strictly in the control flow of the software that's in the syntax. And so you can't eliminate that control flow from the syntax. But if you look at the combinator-based approach, one of the reasons that the combinator-based approach still ends up being more verbose in practice is simply because we have a lot of data abstraction. So the more data abstraction you have, the more you need special language or special constructs to either genericize your combinators or make a bunch of specialized combinators for that specific data structure. And either one of those directions is going to make things more verbose. The things that make APL particularly terse is that it can use an extremely small vocabulary to solve so many things, because it's combining a carefully chosen vocabulary with a single data structure. And the way that people get at that same effect elsewhere requires extra infrastructure code so that they can do their data abstraction. And if you dump the need for the data abstraction and you dump the other stuff, then you'll end up getting somewhere close as well, I think. But the reliance on branchiness and data abstraction, I think, are two of the things that demand extra verbosity.
I understand. Okay.
Yeah.
That's really good to know. That's
because
I don't know how else to think about it.
Right. Well, I mean, this was the classic Lisp comment from like structured interpretation.
I was literally going to say, is like, do we have to mention this quote? There you go.
Gotta always
ahead,
mention this quote, right?
Please
Which is
do,
like,
please do.
it's better to have 100 functions operating on one data structure than 10 functions each operating on 10 different data structures. And so the idea was that you gain more expressive power by being able to say more with a single data structure. Now, of course, the danger of that is you get data protection and data hiding when you use these data abstractions. So if you don't have a good way of managing that, you're in trouble. So you have to have a solution for that.
In defense of C++, I've actually always thought that for C++, the quote is a combination of the two, which is arguably superior than the Lisp quote, which is you have 100 algorithms that operate on 10 data structures. Because of the iterator abstraction, you can use stood find if on all of your vectors, array, linked lists, hash maps, hash sets, etc., because of the way that this abstraction. Now, that doesn't mean that I prefer C++ to APL, but I do think that it is one of the superpowers. You mentioned, John, that we don't have symbols to represent our operations, but we do have this very, very nice set of generic algorithms that you can reach for. I guess the question becomes like, why is that not enough for people like Aaron and I? And it's honestly, your point is a really good one. Like, the question is not, if we lived in a different world, the question is, why do we live in the world? And maybe actually society agreed that this is the best way. And then I have to pause and I have to think, wow, that's a good point John is making. And then my thought is that, well, it kind of feels to me that when I'm writing C++ code or Haskell code, and if you are going to write code like that, 100% use your algorithms, lean towards the collection-oriented programming where you're reaching for these algorithms that work on data structures. But it still feels to me that kind of like we're in this phase of writing math or writing music before the notation was there. The difference being, though, kind of is that like music is this thing that is contained, like a C note is a C note. I don't need to worry about like the thing that's like a C note that's slightly different that I'm going to need to use. Like programming and software and programming languages, it is a general computing thing where we can design the world, right? And therefore, inevitably, what you do with a programming language is going to be wider than the set of primitives, right? Like even if APL gives you 100 primitives, you're going to want to do a bunch of different algorithms that aren't in that set of 100. And you might be able to build those things out of that set, but at some point you're probably going to want to name something, and then you end up with code that it ends up looking like basically the C++ and the Python where you've named a function, unless if you give people the ability to assign new glyphs. But like that's the thing is like assigning a function to a new glyph, like that has, unless if you're coming from a language like Chinese or something where you have radicals and you can build a new glyph out of radicals or something. But it's like, it's a very good question. Is like, there's something there that like the problem that we need something that is general purpose. And so that was, I think, Guy Steele's comment about APL is the reason for its downfall is that your library code that users write doesn't look like the code that the language implementers wrote, which, say what you will about Python and C++, when you write your libraries, it looks like, the standard libraries that ship with them. Anyways, I don't know what the actual question there, but it is interesting to think that that I feel that, C++ functions, they aren't the ultimate, way to write code. But I also think John is totally correct, is that like inevitably you end up writing code that looks like the C++. Like if you look at Marshall's BQN code, most of it is kind of long function names, variable names, etc., structured programming. And it's just that we have this core set of primitives that instead of being a function like std : find if, it's a dyadic iota or something like that.
Right.
And anyways, I don't know if John, Aaron, what your thoughts on all that are.
Well, I've got a dismissive comment about C++, which is that C++ is what we would get if you took the grammar of ancient Greek, combined it with the vocabulary set of Chinese, and wrote it like Mayans. Like this is my.
Wait, that's what you think about C++?
Yeah, it's just like if you take the complicated elements of every single one of the languages and put them all into one bag and mix them up and then spit it out. That's kind of my dismissive attitude towards C++.
I get that. Have you used the new ranges? Oh, they're so nice.
But
by the way,
yeah. Sorry, go ahead.
I was going to say, no, that shouldn't be enough. That should not be good enough. We should always have more. We should always have the ability to be able to describe something better. So no, I don't. C++ isn't good enough. The stuff that it provides isn't. I mean, that might be good enough for me, but that who am I? Like that's. We don't define the upper limits based on. We should not define the upper limits based on the average use case. That's
I will say as a little bit of a call out to the APL and array programming communities. I think we have done a really bad job historically at giving good exemplars of how to solve these problems in a way that is fundamentally different than structured programming. And because like you say, Conor, a lot of people who write APL code, you get a smattering of APL symbols, but then you get basically structured programming on top of that. And in my opinion, that's not good enough to say, oh, well, this is clearly better for APL, right? And so okay, at the risk of sounding like a shill, because I'm plugging a workshop, I am giving a workshop at LambdaConf this year, specifically on this topic, which is like, how do you preserve the simplicity and elegance of the APL, but do so in a way that is suitable to real world? Like, how do you scale up the notation to real world applications? And to me, there's like three elements to that. There's the organization. How do you organize an architecture system so that it's scalable and modular without needing to break it up into explicit modules? How do you deal with describing things like GUIs and interfaces and front end and stuff like that? And then how do you deal with cases where the code is fundamentally branchy? And so I would say that APL, for the vast majority of computational problems, the APL notation it is, if you do good data engineering, your symbols cover pretty much everything. You can do it all. But there is, when you're dealing with systems that have to take things in and respond to them, and these events that come in are very different things, and so you can't batch it. You can't do the whole computation. You can't describe everything. It's fundamentally very casey, very switchy or very if statementy. Traditionally, APLers would just go to switch statements or if statements or something like that. And I don't think that's good enough to be able to deliver on the APL promises. And so event-driven programming, I think, is one of those little areas that the APL community needs to propagate better techniques than just structured programming, which is what they typically use right now. Now, I have a particular method for doing that, and actually, it's the place where I'm most verbose. So my approach is to say, if you can say everything clearly as a specification in an APL, go for that. If you really can't do that, then you better be the most on-point, precise, verbose, system out there. And so the way that I handle event-driven systems, I don't do structured programming because it's not precise enough. I have a different method for working with that it is very incremental, very piece by piece, but it fills the missing gap, I think. And it's sort of the place where I think it's okay to be verbose because we get guarantees a different way. But we isolate that space. We isolate where that happens so that so much of the rest of the business logic does not have to live there. So yeah, basically we can do a lot better. But the problem is that APL and terse languages as a whole have sort of wrapped themselves up in the beauty of the notation without answering people's real needs or questions about how do you actually build full architectures on these things? And what does it look like and how is it different? How do we deliver a real value add at the architectural level and the organizational level?
If you could, like I think you were actually arguing for, if you were able to replace fundamentally computer science education, replace structured programming with this terse functional style, how would you go about doing that? How long do you think that would take?
As far as a curriculum goes, I think you can easily tackle the curriculum at a university level with APL as the starting point, no problem, easy. Because systems like Carnegie Mellon and CMU and those places have already done something like that with functional programming based on combinators, and so I think it turns out that if you teach people data parallel, pipeline data flow programming first, it's not that hard for people to pick that up, and they can learn how to solve problems that way pretty well. The problem is that once you get past that, you need to have a disciplined way to teach them how to recognize when those are inappropriate tools and what to use instead. And that, I think, would need to be in like a second or third year course that you would end up teaching on that sort of stuff. Something that involved GUIs and other things. But your first year courses, your algorithms courses, pretty much all of that stuff, most of that can be handled through the APL notation. Something like a discrete structures mathematics course, your data engineering courses, your database courses, all of those could be based in APL or something like that. And you just, things like your networking, and your systems design courses and your GUI courses, those are the ones that you would need to make sure you've got a good answer to event-driven systems.
How, again, difficult question, but I'm genuinely asking, how long do you think, like if this were fully implemented at every engineering school, how long do you think it would take for the shape of software engineering in the industry to change towards that? I mean, obviously there's going to always be these legacy.
Yeah, 20 years minimum, I'd say. 20 years minimum, maybe 30. Yeah. Because it's very hard to change your software stacks. And even if my proposal is essentially that we can take 10 layers of the software stack and collapse it to one, that doesn't happen overnight, right? You've got to, that's an incremental thing that you have to do. And the points you bring up in terms of onboarding are one of the biggest issues, right? Is you got hundreds of, thousands of programmers out there that don't know these ideas. You can't just bring up a new piece and expect the whole world to change, right? Like the onboarding process on something like that is really difficult, and you can't just push it out top down to every organization. You have to start with organizations that are going to work out the kinks, because there's with agile programming, right? There were early champions of agile ideas that eventually got us to things like continuous delivery, but you have to work those kinks out and understand the social dynamics that are at play and things like that. And I will readily admit that I know there are going to be kinks in how you organize around these ideas, what the best practices are around scaling Tersity, outside of like when it starts to, when like if you've got like my development teams, the teams that I work with that we do, we're really crisp on this stuff because we started with these ideas and we're really explicit about our process and how our style and what it means to be writing good code. So as you get into this, you learn that style and then you make contributions. But if you're trying to butt up against existing legacy code, those are so different that you're going to have to accept a plan for integration. You're going to have to accept, how do you get these teams talking to each other in a way that's productive? And that is a different problem than how do you get your ideal team to be productive when they only have to worry about this kind of programming, right? And so I think that in and of itself is going to that would require a lot of work, because that's that's hard, right?
You said something that really hit me.
Oh no.
A lot of the, like, you said you started out with this, so everyone knows it. It's kind of ingrained, and that's excellent. A lot of the styling choices that I see that are enforced are not for the best code. Enforced in such a way so that everyone, it's like the lowest common denominator of code. Everyone understands it, and it's so frustrating having to work around that. So.
Yeah. Well, that's why we decided not to do that, right? Is we could have written our code to be much easier for somebody to onboard, but we explicitly said, no, we're not operating on the principle of high turnover. We're operating on the principle that we need to solve the hardest problems that are out there. And for us to do that, we need the best facility in our code. So we explicitly decided to give up accessibility for facility. And so that means that we accept that we're going to have to teach the people that come in more about how to work in our style, and they're going to be more confused for a little bit longer, because we're going to have to teach them these extra things. But the trade-off for that is that this will give them the ability to actually solve the problems we need them to solve in our code base. And so that sacrifice is trading the upfront accessibility question for how do we make this the most usable piece of software for us to work with and think and talk about as we possibly can.
Did you ever have anyone push hard against it, like to the point of it being detrimental? You don't have to name names. I'm just curious. Because it has happened
occasionally, occasionally, but we're pretty unapologetic about the approach, and I'm pretty open about being willing to handhold anybody through what we need to do. So we tend to make it accessible because we're socially accessible rather than the code being familiar to people. That we still get some pushback. So it is very common for people who just look at the code that we write to say, oh, well, I write code so that in 6 months I can remember what I was doing, right? That's a very common criticism. And we would say, yeah, we do too.
Yeah,
It's
right,
just
exactly. Yeah, it's all relative.
It's just that, I think there is this element, and a lot of the APL community, I think, has a bit of a pushback against this because they're also still influenced by the software engineering culture that's out there, which is, use those variable names and use the data hiding and some of this other stuff, which, but they use it somewhat lazily. They're not as disciplined philosophically about it, and we've been really careful to be explicit about the kind of philosophy we're introducing into the code and why we're doing this. And it's easy for us because also all the problems we have to solve are really difficult ones. So if this were your typical web app where people are expecting people to churn stuff out, I think people would complain more because they're like, oh, but couldn't you just do this so that so-and-so can fix the color on this one thing without having to find this or that? But we're working on a compiler doing stuff that most people said, is intractable in one fashion or another, or is to this or that. So we're trying to solve hard problems in that space. And because we're doing that, we get I think we get something of a pass because we're specifically tackling hard problems.
Understandable.
Yeah. All right, we do have or go ahead, John.
Sorry,
go ahead. No.
I was just going to say, I also like coming from LLVM and that entire code base, and then looking at what you've written. Holy crap. I don't know how there is so little there and everything works. And then you look at LLVM, which I'm pretty sure has 1 trillion lines of code for the thing. And
nobody can quite see it because as they observe it, right, it starts changing.
Yes, that too. Every day. This is why I have a build server in the next room.
Yeah. Well, I did look at using LLVM as our backend, and I realized that it was shorter, easier, and way faster to simply spit out C strings than to try to link in against the LLVM API.
I will take your word for that. I'm not going to try.
Yeah.
So yeah, the question that I was going to ask is, it's from the chat. It says, basic question: can everything in APL be replicated with normal named functions and parameters? Not all the other stuff in APL or in APL. So how painful
depends on
would
what
that
you mean by APL, right? Like this is the classic problem. What is APL, right? Is if you're just talking about the semantics of APL and the vocabulary that's provided, absent the syntax of functions and all that other stuff, yeah, you can implement those library functions as a library in another language, giving them long names, and you can define an APL semantic compatible array type and pass all your functions through there. And you can get the vocabulary of APL and the data structure of APL. And what you will do with that is nothing even remotely close to what you will do with APL proper. Because the language itself, what you're actually getting when you work with APL is a notational approach that makes working with those data structures and those vocabulary particularly ergonomic. And that's the thing people always forget is everybody in the world could have used the same vocabulary that APL does, because we've known about this vocabulary since the 70s, right? Or the 80s, let's say nested arrays in the 80s, right? Everybody has known about this vocabulary, and no one tends to use it, except in very specific, domain-specific places. And even then, it's not as generic, it's not as general. They don't implement all the parts of APL. And the whole reason I claim for something like this is that the notation in particular makes working with these ideas so ergonomic that you can actually use them at scale. Whereas if you take that notation away, trying to do the same thing in C or C++ or something like that just is not as ergonomic. And the trade-offs that you're making to use these vocabularies don't work as well in these languages because you're trading off too much ergonomics to get the other stuff.
Let me ask this then, as someone who I'm genuinely asking because I don't know, and I'm kind of thinking there may be other people listening who have the same thought here. I am, like I said at the beginning, only familiar with APL specifically the at a general level, based on
Right.
the notation and everything that I saw.
Yeah.
So you're saying in this case, then, um, you said there's only one data model, only one data type, and that's basically the array, correct?
The model that I propose, which is the extremist APL style, is putting everything into careful data engineering in explicit arrays. So there's really only one data type.
So then, based on what APL provides, it sounds like what you're saying. It wouldn't make a whole lot of sense then to try to do something like implement a hash table or some other type of data structure that C++ developers might be more used to, because it defeats the purpose of what else APL provides to solve the problems that are otherwise solved by those other data types. Is that correct?
Sort of, yeah. So I gave a talk at Functional Conf this year or last year on data design in APL, and this kind of covers. I covered this a little bit in that talk, but you can always implement a hash table in APL, but it won't be very ergonomic to use, because the way that APLers tend to work with it is they expose that array model, and then you have a hash table behind the scenes that are running. So when you want to make a map of, say, a symbol table so that you can look up symbols via hash table, instead of explicitly, putting the hash table in your code, you just have an array of these symbols that you look up. But behind the scenes, the APL runtime attaches a hash table to that array. And so when you actually do an indexing function to look for a symbol in there, it will use the hash table to find that symbol in that array. So you know that you've got a hash table behind the scenes, but it's not explicitly exposed to you. And the same thing goes for things like binary search or other types of algorithmic structures. You leverage those behind the array model rather than on top of the array model.
Okay, I understand. And I have to ask now, what is the APL runtime written in? Is it also APL?
So the Codefunds runtime is written mostly in APL with particular kernel elements written in C, which then link into ArrayFire for the GPU libraries. Most other APL runtimes are implemented in C or C++ or some other language like Java. My not so secret mission is to make APL a viable systems programming language. So I want to dogfood my own. The compiler should, as much as possible, be written in its own language, right?
Yeah. Have you written a bootloader in APL yet? I'm trying to think of how low level I can go with this.
I'm working on it. So I'm working on, my first one is embedded systems with no memory manager. So the idea is to completely strip out the memory management stuff, so you don't need malloc or anything like that for the APL code. And then once we've kind of got that, then we go into, can we produce something that is capable of being bootloaded up with a minimal EFI header or whatever you need inside of that piece. It's one of those sparkly things that I want, that I always keep in my head as I'm designing the thing, but realistically it's still quite a little ways away, because we've got a lot of other targets to hit, like JavaScript and web front end and networking and GPU and like. But yes, what I would really like to be able to do is simply compile an APL program as a single bootloadable operating system that you just then run.
That would be awesome.
You can just ship it off to your virtual machine or whatever, and it just does its thing.
No, we're going to run this on real hardware. I'm just letting you know.
Oh yeah, of course. One project I'd like to do is I'd like to make a little like quadcopter, replace a bunch of components for the quadcopter in just APL.
Anything that you can do to, I hate to say this, remove Python from that domain space, I am on board with. So,
well, like there's a lot of math in like stabilization and some of these other pieces that I think APL would be really good at. That I think are obviously good places for APL, but because the runtimes aren't suited for embedded deployment on little copters, they're not used. So that's a place that I would very much like to see APL run.
I'm on board with that.
Yeah.
But that also kind of comes back to, I think, what we were talking about with you were describing with curriculum, and actually a little bit before that too. If we go down to the assembly level, the control flow is definitely encoded in the language itself, branches and everything.
Yep.
And I was thinking, based on what you were saying, the reason that we have a lot of the languages that we have now, like, I mean, C++ and all the other structured languages came about because of the architecture itself.
Yep.
Where that is encoded, and I mean, it's just part of it.
Yeah.
At what point? It's kind of already started to happen, I think, but at what point do you think the hardware is going to start to be, maybe it won't happen, actually, I don't know, but where the hardware is going to be designed for the software instead of the other way around? Because I could...
It is already, I think it is already happening, but I think what you find very interesting is that the hardware is actually getting closer to APL now than it is to other languages. Because trying to get vector lanes and high performance processing and the emphasis on machine learning and these other things, that's all APL-ish type operations. And so APL over time has become more mechanically sympathetic than languages like C, where the compiler is doing a lot of the heavy lifting to get it to match modern architectures. There's still some room to go where you have like multi-level memory hierarchies in GPUs that APL compilers and systems don't quite take advantage of yet. And there are other languages that are currently doing a better job of that, but I think we can get there. And the core model in APL is very sympathetic to modern architectures. And the more things like AI create motivations for people to design array-oriented hardware, the better that looks for us.
You said the magic word in there, by the way, Connor.
Should we? Well, I was gonna say we could just make the last 20 minutes and give. Well, I should say give some of the people what they want. That was one of the keywords to avoid. I mean, I will say as I listen, the topic of AI pops up in my head like all the time. Like, you know, one of the when you both were talking about you know the world we live in today, and that it's, you know, Fortran, Algol-esque, Basic-esque languages. And then I was trying to say that, you know, I feel like there's a better world, you know, APL is a part of that, or some notation-based thing. It's like, and then the phrase that always comes back to me, I first heard from Nick Saris, a multiple-time guest on ArrayCast. He said, you know, APL and other array languages are these languages that enable you to code at the speed of thought, and that is always what I feel like I'm chasing in array languages. It's that, you know, it's one or two types of the keyboard for me to express the, you know, whether Aaron is referring to them as combinators, or we refer to them as glyphs in APL, or, you know, my folds, my scans, my operations. And so that's what I feel like programming in APL enables you to do this. And then there's this little voice in the back of my head that's like, yeah, also too, I can go ask ChatGPT to write that code, and we're not at the point that it does it entirely correctly 100% of the time. But, you know, funny story for the thumbnail of this video, I went and it's, I think, +/2 times iota 10 is the expression. So it's a summation of 2 times a sequence from 1 to 10. I went to ChatGPT because I can write, you know, code like that in like 40 or 50 languages. You know, you don't need to know a lot of a language in order to be able to write that. And in years past, I would just go find some REPL.it or some online, you know, compiler explorer and write it. But these days, you know, the time it takes me to go and import the correct things in C++ and Rust and whatever, like I can just go ask an LLM to do it. But then when I went and asked it to do it for C++, it got it right. But just like, it was so heartbreaking because in Range's land, you can't pipe the fold left algorithm. It's not pipeable for reasons. You know, the committee just hasn't gotten around to it. It's possible, you can't do it. And so I tried to format it a couple times to get it to like, boxy enough to put in like a thumbnail thing. I just gave up after like 5 minutes, and then I was like, do this for Rust. Rust, you're able to do a dot sum, and then it works just fine. All this to say is, the verbosity, bites again, and it's probably just because I'm broken in the brain now. Everything I see is like, oh, it needs to be like, fit in a thumbnail. But the point being is like, how does AI affect all this? Like in a world where you can code at the speed of thought, but the target language is any language you want, aren't we all just going to target some language like Rust that comes with the most compiler guarantees and static guarantees and safety guarantees? And like maybe there's a world actually where we do some kind of hybrid APL AI programming, but it still is going to generate Rust code because that's the safest, fastest, whatever. Anyways, I don't know. We've opened Pandora's box.
Well, in a post-truth world where your code may or may not be saying what you actually want it to say, APL can provide the grounded truth of surety and clarity, even in the context of AI. So it is much easier to look at a little APL idiom that's about to get injected into your code that came primarily from Apple Cart or something like that and say, yeah, that's what I'm looking for. That's right. That is correct. And prove that that's what you actually want, compared to checking that every little piece of that Rust code is actually what you want. It may run, it may be safe, but is it actually what you want? Right? That's the bigger question. And in a AI programming world, the big question is always, is this actually what I want versus anything else?
Well, I mean, I'm sure, John, you would say the opposite, though, because this gets back to the how fluent are you in said language? And like for Aaron, obviously, APL, but like for the average programmer, I would put my $1,000 definitely on the average programmer being able to determine what the Rust code is doing, just based on the fact that they know a language that kind of looks like Rust. I don't know. Maybe, John, you disagree or you agree. I'm not sure what your thoughts on that are.
No, there is a lot of truth to that. Actually, thank you for bringing that up because I was trying to figure out how to introduce this. Most of the general purpose languages that we have they're based on English. There's no other way to put it. There are other languages or versions of languages that are written in other spoken languages, but most of what we have is clearly English. Yeah. And it doesn't make sense to say that, like, we'll just say simple math notation. It doesn't make sense to say, oh, that's English, because it's clearly not. It's its own thing. And I kind of feel that way about APL. But the other side of that is, you actually mentioned earlier, Conor, other languages, Chinese, where, you have entire concepts that are encoded into a single character. And Defense Language Institute says Japanese is the most difficult language for native English speakers to learn for that exact reason, amongst other things, because they're the experts on spoken language and written language and all that. But that's one of the things that I think of when I cannot articulate as well my thoughts into the difficulty of learning it, just because I lack the vocabulary to do so. But that's what I think of when I say how difficult it is to learn a language like that, that's very notational, like that, like APL. If that makes sense. Even if it doesn't make sense, that's still what I'm saying.
No, so. I mean, I not only does it make sense, I think it is just objectively true, right? Like, if something you're trying to learn is based off of something you already know, that just makes it easier. Like, it's the same reason why once you've learned a romantic language like French, it's easier to pick up Spanish, because the gap between some other language that's not in that family of languages, it's just further away, right? So like the larger that gap that you have to figure out how to traverse, the more time and just the more energy it's going to take. I guess the question is it worth it at the end of the day? I mean, I mean, all of us have our opinions, but I think there is like an objective answer, probably, like, what is it though? Is it better to stay and keep things like, I don't actually know, I know what my bias is, but yeah.
There's a hidden danger here though too, which is that the closer the language is, while still being different, the more likely you are to think that you know what's going on when you really don't. And when it comes to like that can be okay in cases where everybody is misunderstanding each other. And I've noticed in a lot of spoken human language communications, everybody is misunderstanding each other. And so that there's a certain amount of lossiness expected. But if you're trying to program something that works and say doesn't have an inherently dangerous security flaw, a subtle shift in semantics can really ruin your day. So for instance, just scoping rules on for loops inside of a system and expecting the scoping to work a certain way. Like you see a classic one would be if you're writing in C and you, instead of putting the int I equals 0 inside the for loop, you put it outside. That would be an easy thing to think is exactly the same. And you might not trigger in your head because you're a Python programmer or a Rust programmer. You might not realize that that I lives on. And then some famous bugs have happened precisely because of that. And that's the thing too. It's just a tiny little subtle thing, but because it looks so close, you think you know what it's actually doing, and you don't do your due diligence because you map the semantics from your previous experience onto that new language. And I've seen a lot of people make big mistakes in their programming because they assumed that it was close enough to what their existing language was. And they didn't take the time to learn the actual semantics.
So this is an argument for...
This is an argument for not assuming that familiarity provides the necessary enhancements to performance that you actually want. I think there's a lot of cost to disambiguating what is and is not the same within a given language. Sometimes it's easier to just learn the new language is totally different. Like for instance, Jonathan, you brought that up right at the beginning, which was that your interaction with J was a lot harder, partly because there was so much overloading to things that looked familiar but weren't actually the same thing. Whereas working in just the APL symbols, there was no way your brain was going to say, oh, this is like this other thing. So you're not triggering any of those confusing pathways. And for people that learn multiple languages at the same time, they say, don't try to learn two similar languages at the same time. Learn something that's in a totally different etymological family, something like that.
Mm-hmm.
And I think people underestimate the amount of misunderstanding that you can get because you think you know what's going on in your code base versus actually knowing what's going on in your code base.
I think that is also an argument that has been made for more tooling, more like static analysis and linting and things like that. And I think that's great. But I also agree with you, we shouldn't need those to understand our code. Those are there to fill the gaps of what we don't know or what we think we know.
Yeah, well, every tool can help, but fundamentally, you can't get away from the fact that once you have lost sight of what's going on, you are inherently facing a much more expensive cost to organize your lack of understanding, whether that's because the code base is so big or whatever is, so I think when it comes right down to it, I think all of this stuff is a question of how do we maximize clarity across the whole system. That would be my goal, is I want maximum understanding of the system and the effects of changes to that system across the whole system so that you can, because the more clarity you have on that, the better your system can become over time. And it's just a matter of how are we going to get there. And there's a lot of debate about how you get there, but I think more verbosity has a tendency to make it harder at scale to get the total picture of your system in exchange for other things. You get something for that, but it costs something too.
Sure. And to that, I would say, this is me continuing my argument. Tersity does shift that balance, where basically reduces the. I would say it reduces the syntactic complexity in exchange for cognitive complexity because of what we just talked about.
Mm-hmm.
And clearly that can be overcome because.
I would say it increases the initial upfront wall. The barrier to entry is higher.
Sure. Yes. Yeah.
And I think it's very hard to argue against the fact that at least in present day reality, the barrier to entry is higher. Now, if you were in a world where everybody grew up learning APL at the same time they learned math, well, then you might be arguing that C++ was a barrier to entry, but worth it because you get all these other things. But in the
If we
present
looked at that
day,
world, I wouldn't be a programmer. I'm just letting you know. Math and me don't really get along, but yeah, I understand what you're saying.
Yeah.
100%. Yeah.
Well, it's interesting
So-
that you say that you wouldn't be a programmer in that world because Alan Perlis is on record saying, and a bunch of other folks as well, that like APL requires a different way of thinking, which I never really necessarily thought that. But then again, I like was love at first sight when I first started playing around with APL. So like maybe my brain works that way, and so like for me to say, well, I didn't need to think different, and like I never experienced that. Well, maybe that's because I fall into the bucket. But that I think about that when you say that, John, like, well, I wouldn't have been a programmer then. It's like maybe it's actually more than what we've been talking about. You know, it actually is that APL. It's not just the symbols or whatever. It is this kind of like there's a certain type of person that their brain naturally is a spreadsheet, and they like thinking of one-dimensional, two-dimensional. Like they would never refer to it that way, but like that is kind of how they structure their thinking. Like I don't actually necessarily agree with what I'm saying. I would like, but when I hear John say, "Oh, like I wouldn't be a pro," and it's like really like for me, all of this, whether I'm skating through Haskell land or C++ land or C land, like it's all kind of different, spellings of the same art form. And I'm happier in some spellings than others for reasons. I can do it more naturally, do it faster. But maybe they're not the same. Maybe that's to like you said. Why is Python and C++ and all these languages? Why are they the lingua francas of today? Maybe it's more than just there's a reason for that. More people are able to map the way that they think to those programming languages and the styles that typically are programmed in those programming languages. And you could probably extend this to Haskell. Haskell is popular enough, but it's not a C++ or, a Java. And there is a different, I think, similar. The functional style is more similar to APL than it is. Anyways, I'll get both of your thoughts on that.
Yeah. I do think, John, if I sat down with you and walked you through the compiler, I think you would not at all find the concept sitting there to be particularly difficult. I think you would. I think people actually. I repeatedly see this when people go through the compiler. They go, "Really? That's it? Well, that was disappointingly trivial," or something like this. This is like that's all there is. And I think that's there is this ethos or mythos that has developed around terse code. But if you design code well and leverage tersity as a technique rather than just trying to make any old syntax terse, I think what you get out is fundamentally simple code. And now that might require more or less work for some people to get there, but I think when you read it, I think you'd be hard pressed to say, oh, this was more complex than something else. And I do think that a lot of people are simply scared because tersity gives you less anchor points to grip onto initially.
So what I was really talking about, I'm not against anything that you said in that regard. But there was sort of the I can't remember the wording, but equating it with math. And all I was trying to say, and really didn't say it that well, was that in that case, it really comes down to a level of quality education, I suppose, because I've been thinking about it, how like I started out, I taught myself programming. I cannot imagine starting out teaching myself math. I mean, even though like clearly had to start somewhere, right?
Yeah.
But I wish I went to a school system that had better resources, so maybe I would have a better, an easier time with it now. That's all I meant by that. Like if math and APL were the exact same thing, then yeah, I wouldn't.
Well, I will say that on my testing, I was always way worse at math than I was at language. So I'm also pretty bad at math.
Welcome to the club.
Yeah.
Right.
Yeah. Conor here could probably whip both of us when it comes to math.
Well, I mean, I was going to
do.
say, as I've always been math inclined. That being said, I did fail a linear algebra course in university, which is
Yeah,
ironic given that I love APL now. But
linear algebra is cheating because there's a lot of logic-y type stuff in linear algebra that's not numerically mathy. Like you don't get to pull on your numerical intuition when you're playing with linear algebra.
it was a theoretical linear algebra course,
Yeah.
and it was all about proofs. And I, to this day, maintain it was not my fault. It was a professor teaching issue.
I'm not sure I've
And,
ever heard of a really charismatic linear algebra teacher in today's world.
I'm sure they're out there, but the problem
I'm
is
sure they're out there.
you
They've
go
got
to
to
a
be
university
somewhere.
and you only get like maybe maximum 2 linear algebra teachers, so you're not really
Have you
getting
ever heard of any, have you ever heard of any bragging about how many people pass their class instead of the other way around?
Oh, I mean, there was a high fail rate, but I don't think it was. It was a first time prof, so I don't think it was something they were proud of. I think they were very concerned at the end of the day. Probably they have some metric too, is like how many students is this a first time fail? And that probably that stat was probably not great for that course. And then in my defense, I took the non-theoretical version and got an A- or something. So believe it or not, linear is just as for some definition of the word easy, it's just as easy as the rest of the maths. There's a lot of
Calculus is the one I hate. I always thought calculus was a sham.
Calculus is the least satisfying in my opinion, especially when you get to like Calc 3, and then it's just I just remember having to memorize like 17 different like derivation and integration rules, and I'm like, this is like the least regular thing I've ever like, oh, we've got an exponent here. Oh, we've got a log here. And now there's just a different rule that I have to go to. It's like the whole point of math and algebra was like you learn two simple rules and then you can solve anything. And yeah, calc is the opposite of that.
Yeah.
Yeah, that's funny. Like, because when I was going through calc, I did great with calc until like we got reduced down to the algebra, and then that's where all my failing grade happened. Was yeah. I understand. I agree with you, Aaron. Yeah.
Yep. Well, so I guess one thing that I would really like to see, because I know we're coming up on the end of the time, is I would like to see more companies try to leverage techniques like Tersity to undermine Conway's law. I'd like to see companies acknowledge Conway's law and then try to break it to build better software, because I think every company ends up suffering fundamentally from their inability to maneuver their code appropriately to adapt to market needs because of Conway's law. And if they can find a way around that, and my proposal is that languages like APL and terse architectures and clear implicit data flow type models can potentially help to remove those impediments of Conway's laws. I would like to see more people trying to see that and see that at more and more scale, because I think it clearly works for 5-person teams and under, or 10-person teams and under. I think it's not so bad. As you get larger than that, you end up having the need for more organization, and who knows? I don't think it's been adequately tested. So I'd like to see that.
Any things you'd like to see, John? As we're saying, final statements here for the Tersity Part 2.
I don't have any original thoughts. I have no thoughts of my own. I agree with that. Honestly, I really do. I want us to have better tools to leverage programming in general, and I am completely on board with anything that makes understanding code and systems easier. I'm just scared of the possibility of going off the rails.
Right. Yep. Which I think is a very legitimate, very reasonable thing to be scared of, especially since we've had decade after decade after decade of doing that.
Right. Yes. Programming by coincidence and steam engines. Yes.
And by fashion.
Yes.
I think of it more as like programming fast fashion.
That is brilliant. I'm stealing that. That's mine now. I'm going to... That is perfect.
Yeah.
Yep.
It'll be
But
interesting.
I will say it's been very. You say you don't have any original thoughts, but not
I
really
don't
anyone else has
anymore.
them either. So I think it's really valuable to be able to come on and talk about stuff like this from like on the ground experiences like what you've gone through.
It's been an honor to be able to do that. I greatly appreciate it, and it's been a thrill talking to both of you, and I really hope to do it again.
Yeah, this has been very fun.
Yeah, and yeah. Don't sell yourself short, John. Multiple times during this conversation, even like right off the bat when you were comparing J and APL, when you said J was more difficult, and it was just because of the overlap of that's something that like I think implicitly I've known, but no one has articulated it like that, and just this idea that the fact that APL has these like your ability to token sequence, you can do that for APL because you don't recognize anything, whereas for J is it two symbols? Is it one symbol? Is that like you don't actually know how to token? So like there's an argument there to say that like in an objective sense, APL is more it's easier to token sequence because you have no recognition of this stuff and you can see, oh, that's a separate thing. That's a separate thing. And that doesn't exist. So like right off the bat, you were already, raining down knowledge from your experience.
A lot of people don't pick up on that. Yeah.
Yeah. Or it's like they might it might be there, but until someone says it, right? And it's like, oh yeah, that's I've had that exact same experience. Like J's not my favorite of the array languages, and that's probably one of the reasons. But I've always just in my head I've said, it's just less readable, and then I feel guilty because it's like, who am I as a lover of APL to call anything like unreadable, right? But then you articulated the exact reason. It's like, well, anyway, so I think you've made that was just the first of many points where I went, that's a good point. I got to think about that more.
Well, thank you. I'm sure glad I didn't let you down.
No, yeah, thank you so much, both of you, Aaron and John. Last things last. Yeah, I think that's it. Are there any, if people want to reach out to both of you, what's the best way to do that? I know both of you are on the socials, but is it via email? Is it what's your preferred platform? And if there's anything you guys want to plug, I know Aaron, you mentioned you have a LambdaConf thing. We'll go to Aaron first, and then we'll go to John.
Okay. Yeah. I'm giving a 2-day APL workshop at LambdaConf, so I hope people will consider going there specifically because I am proposing an opinionated architecture there, which is way more than what you'll typically get at APL trainings. They'll tell you one thing or another. I'm going to give an opinionated recipe for building real world applications and give you a chance to play with them and experiment with them. So I hope people will consider hopping in there and having some fun, and there will be plenty of time for discussion. But email is definitely the way to get a hold of me, arcfight@sacrodeo.us. And I think it should be fun. I also have a couple of talks at LambdaConf this year on some of these issues that we've talked about today. So, I'm going to be, for the first time, I'm not going to be terse at the talks. I'm one of the talks is my favorite verbose programming technique.
Oh wow, there we go.
So we're going to cover that, and should be fun. So yeah.
And John, where anything's to plug, and where can people? What's the best way for them to reach you?
Oh gosh, I wish I had something to plug. No, I don't have enough time in the day to have anything to plug. But if you want to get a hold of me, probably email, I guess. I don't really spend a whole lot of time on social media anymore, or my GitHub, and both of those. So GitHub is JVSTECH, and my email is jvs@jvste.ch. I don't know if you noticed a pattern there.
So how do we read that? Do we say Jarvis Tech?
Sure, that's fine. That's fine. I have no way. So yeah, no, that's fine.
We'll
I just spell it out. That's how I do it.
We'll ask the AIs. They have the answer to everything these days.
That's right.
In the future, we're going to have a fourth quadrant, and it's going to be, I'm not sure if you folks have played around with Manus AI's Miles and Maya that has like a real-time human-esque voice. So at some point, we're gonna be peppering, an AI with what do you think? And
Yeah. You need to train them specifically to be in heavy favor of DSLs.
I'll let you train the AI. That'd actually be quite entertaining. We'll start a series called Aaron Versus, and every second guest will be a new next-gen AI. that is trained to do a really good job arguing with Aaron.
Are they all gonna talk like Obama? Because they need to.
No, well, so
Oh, man.
in that app, there's actually like 400 voices that you can choose from, but I prefer Obama's the best. Yeah. But everyone's got their preference. So. Anyways, with that said, thank you so much, Aaron and John. We'll maybe do this again in the
Thank you.
future, and this has been an absolute blast.
Yeah, absolutely. This has been terrific.
Awesome. All right, have a good day.
Thanks a bunch.
You as well. Later.